Това, с което FameLab е изключително силен, е, че превръща от ученият става звезда мигновенно. Става звезда не само защото бива забелязан от медиите. Става звезда, защото пълни салоните. Освен това, самият учен получава страхотната самоувереност да излезе пред публика и да говори. Причина за това е обучението, през което преминават. Ние непрекъснато го чуваме и това действително вече не е само в България. От всички страни, където се развива лаборатория за слава FameLab, един и същи коментар чуваме. Обучението, на което те са подложени, не само ги подготвя за финала, всъщност ги подготвя да говорят пред инвеститори, пред банки, да си пишат по-добри проекти, да говорят пред журналисти с по-голяма увереност. Всичкото това довежда до едно по-лесно говорене с публики във всякакъв формат. Това беше причината да поискаме. Освен това, защото FameLab е още добър и в една много важна област и това е да разбива на пух и прах митовете за скучни, стари, некомуникативни учени. Ако видите хората, които идват на сцената на FameLab, те са всичко друго, но не и безинтересни. Трите минути са... Първо, защо са 3 минути? Защото целият формат на FameLab е предназначен към точно вас, към медиите. Трябва да бъде достатъчно кратко и достатъчно пълно със съдържание, така че вие медиите да можете да го отразите. И за това 3 минути. Изглежда много малко време, но всъщност страшно много може да се каже, пък и Айнщайн на времето го е казал, ако не можеш да го кажеш кратко, най-вероятно изобщо не си струва да бъде казано. Или нещо такова. Така, тези 3 минути протичат с заявка на тема, разработка и нейният край. Това може да бъде както разказано с думи, така и изиграно. Може да бъде, ние сме виждали рап на сцена, между другото един физик, който рапираше с една формула за фрикция. Виждали сме живи експерименти на сцена. Това, което не може да се случи е PowerPoint презентация. Тоест, не може да се случи скучна лекция, не може да се случи да четеш. Можеш обаче да пееш, да танцуваш, да говориш, каквото ти е подходящо за темата. Обикновено казваме, че тя трябва да бъде разказана така, че твоите приятели и близки да разберат. И всъщност, ако трябва да бъда честна, има още един тест и той се нарича любов теста. Аз съм казала, че ако аз я разбера, целият свят ще я разбере.
Welcome to the FameLab International Final 2012. Please put your hands together for Quentin Cooper.
Thank you very much. Good evening, football fans. Yes, don't worry, you're not missing Ukraine v France at the moment. The pitch is waterlogged, apparently, so this play has been suspended. I will also try and get the whole thing over before the Sweden-England game as well, just in case. Does anybody care about football here? Now, I did mention Euro 2012. Bear in mind, for the few of you here who do care about football, this is a tournament with 16 countries taking part, going through to semi-finals where there will be 4 teams taking part. FameLab has 19 countries taking part, going through to tonight's final from the semi-finals where there are 10 taking part. So in every sense, you are on a far bigger occasion than Euro 2012. Far more hangs upon this as well. Okay, well, suffice to say, this is the climax, and I hope I'm not using that word prematurely, of a worldwide global hunt for great science communicators of different kinds. People who can, in 3 minutes, can not only convey the facts, but the excitement of science on some scale, from the subatomic to the spectacularly galactic. Don't mind a bit of hesitation and deviation. What counts is imagination and illumination. Anything else you need to know, you can figure out as you go along. Even if you are new, being the kind of sophisticated, science-savvy crowd that you are, I'm sure you've already spotted that FameLab International is an anagram of fatal to 9 lame brain. And that, of course, is almost uncannily true, because for all that they've achieved in getting here, this next hour and a half will be fatal to the hopes of 9 of our 10 finalists. I'd love to say we planned it, that it was a message hidden in the lexical DNA of FameLab International, left as a clue for all that enter. It is, after all, no more ridiculous than the plot of Prometheus. And the 3D's better here as well. But it is, of course, just chance, and it is, of course, cruel to say lame brain. Each of our 10 finalists have battled through local heats, national finals, the international semi-finals on Wednesday to get their 3-minute slot tonight. So even though only one of them can walk away being crowned the champion of champions, the FameLab International Supremo 2012, each has more than earned their right to be here. They are anything but a lame brain. The same, of course, cannot be said for our 3 judges. Please welcome former Science Supremo at the Daily Telegraph and editor of The New Scientist, now head of many things at the Science Museum, Roger Highfield. Comedian, King Arthur a lot in Spamalot, Radio 4 highlight, guest festival director, it's the big, smart, cocksure, that's an anagram, Marcus Brigstock. And our guest, our chair, is the director of the entire Cheltenham Science Festival, well, co-director, TV's Kathy Sykes. First up is from Israel, it's Yael Grossman. Yael has many interests, including music. She plays the violin, but she says that she's been fascinated by computers since she was 3. And now, as an MSc student at Tel Aviv University, she's trying to give some of that fascination back by getting computers not just to answer questions, but to ask them in interesting ways and to be creative. We've been trying the same with our judges. If they don't manage it for Yale, it might be worth mentioning another of her interests is karate. She has a black belt. So up first, which is always a little harder, so please whoop and holler or make other sounds of your own choosing for Yael Grossman.
Hi, I've been playing the violin for quite some time, but what I'm about to play you now just blew my mind. See if you can figure out why. Sounds familiar, doesn't it? The thing is, this piece was composed by a very talented computer. Meet Emily Howell, a computer program created by Professor David Cope of Santa Cruz University. Emily's music has been applauded by audiences who had no idea that Emily was not, in fact, human. Even music experts couldn't tell the difference between Emily's creations and those of famous composers. Do you realize how incredible this is? Let's take it from another angle. Imagine you just met someone online, you're chatting, it's a great conversation. But what if you were to discover that the charming person at the other end isn't even human? It's a computer program, and you had no idea. This scenario was envisioned 60 years ago by the father of computer science, Alan Turing. The Turing test determines that if a person interacts with a computer and another human being, but can't tell the difference between them, that machine is intelligent. By this criterion, Emily may be an intelligent composer. So what's the secret? How can a machine make music? Emily contains a database of thousands of classical works. Professor Cope has broken them up into building blocks, creating a musical language. In the same way we construct sentences based on grammar, Emily composes meaningful melodies based on music theory. That's how Emily creates music. But seriously, guys, come on. We all know this isn't real creativity. She's just putting together bits and pieces of something somebody else wrote. Real musicians compose from bleeding hearts and tortured souls. David Cope begs to differ. He claims that even Mozart and Beethoven composed their great works based on a similar database in their heads. Folk songs, bird calls, maybe lullabies. And that true genius lies in the ability to combine these inputs, creating something new and original. So that just leaves us with one final question. Who are we to say that Emily isn't at least as creative as our very own personal computer? Thank you.
Не е наша работа от гледна точка на една културна организация да коментираме проблемите в една наука. Ние можем да кажем това, което сме видели като пример от Обединеното кралство. Преди 20-на години, по времето на управлението на Маргарет Тачър, тя излиза и казва небезизвестната фраза: спираме финансирането на всички публично финансирани области, ако те нямат публична подкрепа. Така, публичните средства и в наше време намаляват, това е факт навсякъде. Един от начините, по които можеш да направиш публиката свой партньор от една страна, е да представиш пред тази публика какво правиш. Учените от Великобритания са започнали да правят точно това през 80-те години, да градят систематично системи от представени от различни формати, от различни събития, които представят наука пред хората на всякакви възрасти и във всякакви обстановки. Това са, като започнем от спектакли, мине се през всевъзможни конкурси, дебати, състезания, лекции по телевизията. Между другото, има коледна научна лекция, която се изнася от член на Кралската академия. Това е аналога на Академията на науките. Това е семейно събитие. Има сайенс центрове, т.е. центрове за наука, която може да се пипне, да се експериментира навсякъде. Има образование по комуникация на науката. Има професия комуникатор на науката, за която има бакалавърска, магистърска и PhD, докторски степени на образование. Тоест, цялата система е разработена така, че да бъде преодоляна тази пропаст между обществото от една страна, широката общественост и науката. Нуждата от преодоляването е защото общността финансира със своите данъци, финансира науката. Науката трябва да бъде прозрачна в начините, по които харчи тези средства, но също така и да казва какви са разработките. Повечето големи политически дневни редове в наше време се формират от въпроси, свързани с наука, като вземем промени в климата, стволови клетки, за и против ГМО, каквото и да е наоколо. Това са все въпроси, които, ако щете, дори и 2012 дали е края на света.
Now next, Brendan Mullen, who is our first ever finalist from the USA. Now he won a special NASA version of FameLab that was only open to astrobiologists and specifically grad students and postdocs doing research related to astrobiology. Now you expect people to come from NASA to Cheltenham to tell us about all the amazing things they've done. I think it's great that NASA have taken an idea from Cheltenham and exported it to themselves. So this is a real sign of what FameLab has achieved. It's something that's actually broken the barriers of NASA. Even worse, I should say, is that Brendan claims to be, in his own words, a Nordic skiing, science writing, outreach practicing PhD student in astronomy, but he can match that reputation. He says he likes his conversation light but his beer dark, which may prove relevant. And I should say that the NASA final he won was hosted by Nichelle Nichols, who you might remember was the original Uhura in the original Star Trek. I'm not sure why I'm mentioning this, because the rest of this evening is going to seem a bit anticlimactic now, I'm afraid. I am a mere science communicator. She is a science fiction communications officer. I am comprehensively outranked here. Still, even if we do not have Uhura, we have the person who won the final that she chaired, and that person is Brendan Mullen.
I love a good beer. This stuff is remarkably simple, you know? Just atoms, hydrogen, carbon, oxygen, nitrogen, and a few other types, all bound together in many different but all wonderful arrangements. Do you ever wonder where the atoms in here come from? Well, hydrogen, that's been around almost as long as the universe itself. It congealed the primordial energies that filled the hot young cosmos over 13 billion years ago. Which kind of makes hydrogen like the hipsters of the atomic world, you know? They became matter far before anyone else thought it was cool. So now they're just, being massive just to be ironic. But for the rest of the elements, we looked at the stars. Stars are all distant suns, nuclear furnaces that spend millions to many billions of years smashing lighter atoms and other particles together to make heavier atoms. But stars don't live forever. Some grow sick and bloated, coughing up some of their insides, before heaving their outermost layers into space. Other more massive stars, well, they take the Hollywood action movie approach and die in overly dramatic explosions, supernovae that can be seen clear across the universe. But no matter how a star dies, our cosmos ends up littered with its stellar guts. And these mix into great clouds of gas and dust between the stars, and they roil and slosh around like your stomach on a roller coaster full of energy drinks and airport food. And after millions of years, some of it bunches up and collapses down to form new stars and new planets around them. It's how our solar system was formed. So everything on this planet, and this beer, is star stuff. And you might have heard this phrase before, star stuff. But it doesn't tell you how many stars donated their stuff for this beer. I mean, the atoms in here didn't come from just the death of a single star, no. Just like brewing the perfect beer, brewing an entire solar system takes just the right mixture, proportions of ingredients. Carbon, oxygen, and the rest forged over billions of years and contributed by many ancestral suns, at least in part. So do you want to know how many stars had to die over cosmic time to give us the atoms in here? About 10,000. 10,000 suns, all long gone, to give us a bottle of beer. Well, I don't know about you, but I think it was worth it. Cheers, universe.
Thank you. So the Olympics and Euro 2012 come round every 4 years. The solar cycle's almost every 11 years. And every 24 years, the Swiss get a Canadian into the finals of a major international competition. Last time they persuaded the absolutely nothing to do with Switzerland Celine Dion to enter Eurovision in 1988. She won and became an international superstar. This time it's the equally Canadian Beshara Saab in International FameLab 2012. Now, he does have slightly better Swiss credentials than Celine does. He's based there, he's working as a postdoc researcher at the Brain Research Institute at Zurich University, looking at the cellular and molecular basis of curiosity. He's already established it can be fatal to cats. But there's still more work to be done after we've seen some Swiss role-playing from Beshara Saab.
I implore you to take a look at the sky tonight. Between now and sunrise, you'll be able to see 5 planets with your naked eye. I was staring up at the red planet last night, thinking to myself, whenever it comes for me the opportunity to live on Mars, I will go in a heartbeat. And I can tell you 3 reasons why. Imagine that you live on an island in the middle of the ocean, and that on your island there is a myth, a legend, that every so many generations a giant wave arrives, tall as the moon, and wipes out your civilization. Also imagine that on the distant horizon, and perhaps only on the clearest of days, you can see a second island, but you have no way to get there. And then someone invents a boat. Would you take that boat and go to the second island? You might go out of pure curiosity. You might go as a means to safeguard your civilization from the next cataclysmic wave. These are good motivations. But perhaps the most compelling reason for you to go to that second island, or for me to go to Mars, is what we might learn. Despite its fiery appearance, Mars is much, much colder than Earth. You can't wander around in bare feet. No. To live on Mars, we would have to terraform it. We'd have to change the climate to make it a little more like Switzerland. And this is not science fiction. It's possible on Mars because there are huge reserves of carbon dioxide frozen at the polar caps and elsewhere on the surface. And if we could add just a little heat, we could release so much CO2 through a runaway greenhouse effect that the pressure and the temperature on Mars would be thick enough and hot enough that liquid water could flow. Scientists suggest we could do this by smashing asteroids into the planet, or by exploding hydrogen bombs, or even with super space mirrors that would redirect sunlight onto the polar caps. But probably the most practical method would be for people living on Mars to release hydrocarbons. We already know a little bit about how that works here on Earth. And then after a few thousand years of introducing more and more complex plants and animals, there would be enough oxygen on Mars that my great-great-great-grandchildren could run around barefoot and without any scuba gear. So in addition to satisfying our curiosity and helping protect the community of life from events that, for example, killed the dinosaurs, going to Mars could teach us things that we cannot yet imagine. We may even learn how to control the climate back here on Earth. So tonight, please, when you leave here, take a look up at the sky and find your second island.